most of the programming languages work when we have two parameters. If we fix, we have two parameters. Now, so you already have a hint of why pre-order traversal is part of it, because that's actually how most of your high-level language work. You have the operator in front, and you have the operands. Now, of course, post-order traversal is somewhat okay as well. Now, the rule to look at the post-order traversal is you wait for two valid operands before you work on it. So here, 3, 6, and you see a multiply. Then, of course, you already see 3, 6, right? So you get 18. 18, 1, and plus. You add them together. Okay, so it's also okay. So that means if I have a child now, that is real human. Instead of teaching them in-order traversal, they can actually operate on pre-order traversal and post-order traversal. Okay? Just like normally. So that's why computers can all do that. Okay? Now, another thing about the traversal is that, look at this tree. Now, this is a very similar tree with the same leaf nodes just now, but it is a different tree, right? Now, here, the multiplying operator is at the root, and the plus operator is child. Now, if I evaluate this, then immediately know that I do 6 plus 1 first, becomes 7, and 7 times 3 is 21. So this is a different tree. Now, but if I do an in-order traversal, start with test again, 3 star 6 plus 1. Now, the in-order traversal of this tree is exactly the same with the last tree. Right? 3 times 6 plus 1, 3 times 6 plus 1. Now, so here, if I want the in-order traversal to represent itself correctly, I need parentheses, right? I need to know that 6 plus 1 actually have a high priority here. So here, this is actually represent 3 times parentheses 6 plus 1. Okay? Now, you see, where is the parentheses here? You don't actually see the parentheses here. So is my binary tree or represent mathematical expression fatal? No. Let's look at the pre-order traversal. Times 3 plus 6, 1. Now, let's use again a C understanding of this. So here, this one will become multiply 3 sum 6 1. Does it give the right answer? Yes. Okay. So here, the pre-order traversal star 3. I will type it here. Star 3 plus 6 1. Okay. And the previous tree is plus star 3 6 1. Now, the two trees have the same in-order traversal, but their pre-order traversal are different, and it leads to the correct outcome, even if you pass it. Now, so something may be of surprise to you. If you use pre-order traversal, you actually do not need parentheses. Okay? Among all the expression orders, the in-order traversal is the weakest. It requires parentheses to solve ambiguity. But if you do pre-order traversal, you don't have ambiguity. Okay? That is also another reason why the machine would prefer this order of notation. Okay? So you see here, you get the idea, right? You don't need any parentheses when you use pre-order traversal. Now, this is the same for post-order traversal, though it's slightly harder to see. 3 6 1 plus. And then the 6 1 will be added together first. The plus will all get the closest together. And it will become 7. And then 3 7 will be multiplied together. Okay? So you can train yourself to find the answer in both pre-order traversal and post-order traversal. Now, so the only one that needs parentheses and have ambiguity is the in-order traversal. So here, we can see that the in-order traversal can be misleading. Okay? It will need parentheses to calculate properly. Now, in the Polish notation, that is the pre-order, and also the reverse Polish order, we do not need any parentheses. Both notations allow an expression to be evaluated correctly without any parentheses, which is considered far more machine-friendly. Right? If you write a program, obviously you want, if it's very complicated again, then you want to pass an expression and then it will store it in a way that provides no ambiguity. Now, of course, ultimately the tree itself, of course, have no ambiguity at all as well, because the pre-order traversal and post-order traversal comes from the tree. So actually the tree is a very good way to store it, rather than the string. So you imagine when I have a mathematical expression, I would rather store it in the expression tree. So here we have actually see how the tree can represent something better than a string, okay, or at least than a list of things. Now, we actually have something called reverse Polish calculator. Now, in a reverse Polish operator, we actually input two numbers, and then we do not need the equal sign. Okay, we just input the operator, and then it will be calculated. Have anyone used a reverse Polish calculator before? No. Okay, I have. Okay, that's how we save time. When you have, my father also as an accountant use reverse Polish calculator because it's fast, right? In normal, in an in-order calculator, that is the one you use. You need to add 3 plus 1 equal, then you need 4 keys, right? To a reverse Polish calculator, 3, 1 plus, they get an answer. Now, of course, things can be very difficult. So ultimately, if you want a very complicated expression, you will need a parenthesis, or you need to put the order in your calculator. But if you use a reverse Polish calculator, you can do it like at some insane speed. Now, I believe you sometimes in the shop, you see some accounting clerk doing the calculator like some insane speed. It is possible they are using some very old style calculator that use reverse Polish notation. It's actually, I don't know whether it's still available for sale, but I believe you can download some program. But I don't believe you do accounting. So I don't believe you need that, correct? You just type in the expression, and the computer will pass it for you now, right? So this is a thing of the past. But if you are really interested, people once believe that this is the future of calculators. But ultimately people find that too hard to use for non-engineering, non-science people. Okay? You really ask an arts person and ask them to, throw away what they have learned for like a decade and then do the reverse Polish notation is a bit hard. Okay? But if you're interested, remember, okay, this is actually a very good way, the quickest way to do any calculation. So actually, that is it. Okay. Now create a binary tree from a string is what we call parsing. Now parsing is to change a human expression into usually a tree. Okay. Now that is actually a very general way. Okay. Now it spawns a completely separate field called natural language processing or any kind of processing. So if you're interested, you have many courses, a full course for this. Say you create a compiler. Say you go a course and talk about compiler. The very first thing they need to do is to parse your source file into a tree. Okay, it's always a tree. Okay, or if you want to say understand human language or voice recognition, ultimately they need to parse your language again into a tree. Okay, so this is a very deep knowledge here, and we will end here as the only thing that you will know how to parse, because for the rest it's very difficult. Okay, for the rest it's very difficult, but you get the idea. Okay, if you're interested one day, natural language processing, and one of them is parsing. See here, I am parsing a sentence. The white cat sat under the chair. Now in this case, I will use English grammar to try to parse it into a non-binary tree, because English is not binary. Okay. So here I have the sentence. The sentence have a noun and a verb, right? NPVP. And the noun clause here, noun phrase here, the white cat. Okay? The white cat is a noun, right? And the white cat can be passed into the, which is the determinant adjective, white, and the cat. Okay? It must end with the cat. And then I have a verb, set, and then I have a preposition, under, and then I further have a noun, the chair. Now, when they do the parsing, they will end up with a tree. And they can check if the grammar is okay. Okay? That is the foundation of your grammar checker in your word processor. So they try to pass the most reasonable tree, and if they can do it, they believe the grammar is okay. So there's a limit to this because there are many ways to pass a sentence. Sometimes it appears to be okay, but it's not okay. Sometimes your sentence is actually okay, but they cannot construct a tree, then they say it's not okay. Okay? So this is actually one of the parsing. Okay? And here, this is example. I saw an elephant in my pajamas. Now, it can be passed in two different ways. The correct way is that you are wearing a pajama and then you shoot an elephant. So you shoot an elephant in your pajama. Okay. The other is actually wrong because you try to shoot elephant in, well, usually the sentence is, I shot an elephant in his legs or something like that. But you shot an elephant in a pajama, which is the pajama belongs to the elephant. Then that past tree will be wrong. Okay. Now, the reason I don't talk about past tree is that some of you don't even get which is the correct past tree. Okay, because it requires very good English grammar. Okay? Now, not to mention Chinese parsing. Wow, that is the hell break loose. Okay, so in a way you can realize, okay, that is actually a very deep field. That is developed for many years, but still not perfect. Right? You take out your iPhone and you try to use your Chinese to honestly or even English, and ultimately only the very simplest sentence, okay, can be parsed correctly. Okay, and C, parsing tree. Well, you see, now this is a C parsing tree, which you have written for a long time. When you write a C file, what do they do? It's a program, and then you realize each one of them is a statement, and then each of the statement, then they pass it out. You realize that it's a variable. I notice an equal sign, and then the rest of the expression. Okay, so it will pass into a tree. If that tree is failing, it can pass everything into a tree. It says it can compile. Okay? If it fails to pass something is wrong. That does not fit anywhere. Throws an error. Okay, so that is what is happening behind. Okay. Your C program, ultimately, when they do it, it actually becomes a tree. So you have been writing trees all along, okay? That's what we have been doing. Any questions on binary expression tree or not so binary expression trees? Now we will take a small break, okay? And then we will come back and actually talk about something not, okay, about parsing using expression tree. Anyone who are late?